With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is propanamide when reacted with Br2 and KOH we get A, and then we treating it with this we get B. So we need to tell here B is. Okay, so we need to tell what B is going to be. So here 4 options are given to us. So let's see what is the structure of propanamide. Propanamide is this CH3 CH2 C double bond O NH2. This is our propanamide. Okay, and this is our nothing but ethyl group. So I will write further it as ethyl group ET. Okay, ET is nothing but ethyl group, that is C2H5 or CH2CH3. Now what we are doing is we are treating it with Br2 KOH. So let's see Br2 KOH. So whenever we treat it with Br2 KOH, what is this? This is our nothing but Hoffman bromamide degradation reaction, right? This is our Hoffman bromamide degradation reaction. And what will happen here? What we do is we take 1 mole of Br2 and 4 moles of KOH in this reaction, and what will happen? This CO is removed and you will get CH3 CH2 NH2. You will get ethylamine. Okay, so this is what is going to be a product A, right? So now let's see the mechanism for this, for the Hoffman bromamide degradation. So what happens is here is we have our ET, that is CH2CH3 CH2CH3, that is C2H5, ET C double bond O and NH2, right? And also, as I told you, we are taking 4 KOH. That means we are taking KOH is what? It is a base. And we know that the hydrogens attached to heteroatom, they are acidic. So this hydrogen will be acidic because it is attached to heteroatom. Heteroatom, that means any atom other than carbon and hydrogen. So here nitrogen, and of course it is more electronegative. So this hydrogen will be highly acidic. So when KOH can be broken down like this, K plus NOH minus, right? So I'm just taking OH minus directly. What it will come in, it will take this H plus and this will go like this, and we will get ET C double bond O, ET C double bond O NH minus, right? This is what we are going to get. So now what will happen in the next step? As I told you that we have taken 1 mole of Br2. Next step, Br2 will come, Br. Okay, so this negative will attack on one of these Br atoms from in the molecule like this, and the 1 Br minus will leave. Okay, so what you will get? You will get this ET C double bond O N hydrogen Br. So this compound, this C double bond O NHBr is known as bromamide. Okay, that's why this reaction is known as Hoffman bromamide. Hoffman because Hoffman was the scientist who gave this. Bromamide because of this formation of this bromamide process, and degradation because further CO2 will be removed. So that's why this is the name of this compound. So this bromamide will form. Now in the next step, what will happen? As 1 hydrogen is still present, which is again acidic because attached to a heteroatom. So again OH minus will come, as we have taken 4 mole of KOH, right? So again this will come, take this hydrogen and will give this N minus. So what will happen? You will get ET C double bond O. Let me write this again. ET C double bond O N Br minus. Okay, now see, this minus will not attack on Br2 again. Why? Because in this reaction we only take 1 mole of Br2. Alright, so that's why no other mole is available, so that's why it will not be able to attack on Br. So what will happen in the next step? See, I write this here so it will be clear to you. This is ET C double bond O N minus. This is very important step. So what will happen? See, this N minus will go like this. Okay, and then what will happen? This ET minus, this C2H5, this ET, it will migrate. As ET minus, it will migrate on this nitrogen. It will migrate. Okay, here this migration of this ET minus is taking place on this nitrogen, And when this Et minus comes and attack on this Br minus will leave as a leaving group. Okay, so here this migration is actually happening. So what you will get as the product, you will get this. You will get your cyanate, that is Et N double bond C double bond O. So this is known as your ethyl cyanate. Okay, alkyl cyanate because alkyl group is here. So this is your ethyl cyanate. Okay, so now this step, this migration that took place here, this is your RDS step. This is your rate determining step. Okay, so now what will happen? This cyanate will treat it with water. Okay, when we will treat it with water, what will happen? See, here if you see this nitrogen and this carbon, nitrogen will be what? It will have partial negative charge, carbon will have partial positive charge, right? It will have partial negative, partial positive. So what will happen? Because nitrogen has lone pair, right? So what it will do? It will attack on H plus from here, from water molecule. It will attack, this lone pair will go and attack on this H plus. And what we will get? We will get this R, NH, right? And of course, water is, we have broken down water as H plus and OH minus, let's say. Let's say we break it like this. So N minus, because it will be having a partial negative charge, this will go and attack on this H plus, right? And similarly, because this is having partial positive charge, O minus will go and attack on this carbon. So what you will get? You will get this C double bond O, OH. Okay, here oxygen also has lone pairs. Why it is not? It will not, but it will also attack. But this will be the major step. Okay, this will be the major that nitrogen is attacking. Why? Because further on, when we get this kind of a structure, later on when you heat it, on heating, this CO2 is removed from here. This CO2 molecule is removed from here, and this is the driving force of this reaction. That's why this is the major product. Okay, I mean this will be the major step. Oxygen will also attack on H plus, but here we will get this as major product because further in the next step on heating, CO2 is removed. Okay, whenever a gas is removed, the reaction is favored. So what you will get here? You will get this R, NH2. Okay, where your R is nothing but ethyl group, R is nothing but ethyl group. So you can write it like this: CH3, CH2, NH2. That is your ethylamine. Okay, I just showed you this is your product A. I showed you how we made this. Now in the next step, what we are doing after A, we are treating this A with HNO2 and then with red phosphorus HI. So let's see what will happen. Okay, so ethylamine was formed. That is your CH3, CH2, NH2. Right, now this is your A. We are treating it with what? HNO2. First we treat it with HNO2. So what will happen whenever we treat amines with HNO2? They will give us, it is a method basically to prepare from alkyl amines directly to prepare alcohols from alkyl amines. So what you will get? We will get this intermediate CH3, CH2, N, triple bond N with the positive charge over here, N2 plus, and then later on when you treat it with water, N2 gas will be evolved and you will get CH3, CH2, OH. You will get ethanol. Okay, so this is your ethanol which is going to form. Now what we have done in the next step, we have treated this compound with red phosphorus and HI. Now we know that HI, red phosphorus HI, is a very strong reducing agent. They are very strong reducing agent. So what it will do? It will reduce this completely. Alright, completely means this OH will be removed and on this place hydrogen will come. So what you will get? You will get your pure alkane, that is CH3, CH3, that is nothing but C2H6, which is known as ethane. Alright, so this is your molecule B. So in the question they have asked us what is B? B is ethane. So your option C is the correct answer and the rest are incorrect because they are not forming in the product. Alright, so I hope you understood. Thank you so much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.